All right, let's do a little sound check here. Looks like sound's good. You guys should be able to hear me. We're going to go through Unit 11 of the Linux Systems Administration course. We're going to capture some of the things that we talked about yesterday, and then I'm going to work through some more things, hopefully add a little more color commentary and knowledge to this. But for those of you that haven't been tracking along, we've been running through a 16-week course on Linux Systems Administration designed to take you guys from being amateurs that do this stuff for fun and help you move over to maybe being professionals that do this stuff, for work. So this week, let's talk about what we're doing. This is our 11th meeting. You can ask me questions up in Discord. If I had any announcements or reschedules, they'd go here. And then quick reminder, hold all your exercise sheets until the end. We have exercises and stuff that I'll show you and labs and all those things. And you can keep all that until the end. And only the people who actually finish will bother to turn those in. All right. So last week, what did we talk about last week? Last week we were finishing up containers in Kubernetes. So we had a few questions around. You had to read this Kubernetes IO, kind of like this overview. And you had to kind of write up as a discussion post what was interesting to you, what you didn't know, what you thought would be good for Kubernetes in the enterprise. We talked a lot about how containerization is great when you're developing stuff, but it's very hard to productionalize containers by yourself. Like taking a bunch of devs that are just running Docker and Docker Compose commands on a system and putting that into a shared space, it's a nightmare. It's a nightmare. You only have so many ports open, and it's just it's better to use a tool like Kubernetes where we can define how those containers that they build come in through pods, and then we can lay them in and let all the networking happen automatically. So we talked about that. Then we had a ticket coming into the cluster, and you had to go look at what was going on. You got some information, and there was just an error going on, and you had to look at it like a Linux systems administrator would. Even though you might say, well, Scott, I'm going to be a Linux administrator, not a Kubernetes administrator. Yeah, but that's the thing, guys. When you do Linux, the first thing everybody thinks about you is you know everything, right? That's just a thing that happens in the industry. They're like, this person solves problems. We'll put them on all the problems to solve. That happens a lot, too. Actually, that's a good... I've had a whole career full of being put on stuff that has nothing to do with me, but that's good because then now people know your name and they know that you're somebody who helps to solve problems and stuff. And then the last one is... you're the NOC lead, right? So you're the head Linux administrator or head monitoring person in wherever you're at, and you have to write a procedure about system checkout. Like, how do we know the system's good if a little light comes on before we call somebody? That kind of stuff, right? So then that was last week. Then we did some worksheets for last week, and we had our lab. This week, we're going to talk about monitoring and monitoring systems. And again, we're focusing on the administration side, not the engineering side. On the engineering side, we build everything. On the administration side, we run things and maintain them, right? That's kind of what we do. I was telling you guys, I kind of liken it to being a pilot, where a pilot just needs to know how to keep the plane going. The pilot doesn't need to know all the physics and forces behind it. It's probably useful for them to know those things, but a pilot might not know every linkage between where they're going like this with their throttle and everything back to the engine. They might not know all of that. They might not be able to draw that out, but they know how to keep it going within the parameters. And that's kind of what an administrator does, right? Whereas we want to focus on eventually being over as an engineer and knowing all the inner workings, but that's not the start of it for us here in this course. So anyways, discussing the loose coupling and then digging into Prometheus PromQL language. Then on the worksheet, there's some notes, and then there's a lab with the lab guide and all that stuff. And then the project, I just want to ask a little project check. If you're doing the course with us, how are you doing? Have you at least built something by now? So if you guys are wondering, well, what's this course he's talking about? In our Discord, if you go down to ProLUG projects, there's all the projects here for all the weeks back. All the worksheets, all the labs, everything, all the discussion posts about, and this week is a section on what is loose coupling, right? So let me pull up the administrative guide or the worksheet real quick for you guys, and we'll talk through that real quick. So here's the questions. In the worksheet, I say to hold it till the end. Here's the first discussion question. You've heard of the term loose coupling. People have been throwing that around in the office about this new monitoring solution that's coming in. And a lot of times when you're on the administration side of things, you're not always making decisions. Things are happening around you, and you have to support them. So you want to go find a good resource on loose coupling, and you find this thing called the SRE Google Workbook. Now, I've told you guys SRE.Google will have a bunch of free books for you. And then in one of their books, they've got a monitoring section. And in that monitoring section, or in that monitoring chapter, there's a section on prefer loose coupling. And I tell you to go read about it. That's your discussion post. And then I said, what does loose coupling mean if you had to summarize it to your junior team member? So you can think of that like one of those explain it like I'm 5. Break it down to the simple pieces of what does it mean to be loose coupled. Well, real quick at a high level, if you guys have ever used a tool like Nagios or something, Nagios is this big monitoring tool that you put in an environment, and it goes and checks everything. It aggregates it all up. It stores all the states of things, and then it presents it in a web page. So it is a big, what we call monolithic application. It does everything. If Nagios is down, you are not tracking things anymore. You are not collecting the state of things over time, and you are not presenting it because Nagios is a big monolith, right? But loose coupling, and the way that we kind of do a lot of our monitoring now, is we have an end piece like Grafana doing all the visualization. Then we have something aggregating, so some tool in the middle being an aggregation piece, doing maybe like a time series database or some type of like API and then aggregation to a key value store or something like Loki does. Or like another time series database is InfluxDB, and they're just sitting there, and then you've got a bunch of tools either pushing data or getting data pulled from them, and Prometheus is a big example of this, right? Like Prometheus is a very common one of these, but Prometheus doesn't need Node Exporter. Everybody thinks like, oh, I'll use Node Exporter and Prometheus and Grafana. Cool. That is a loose coupling of a few different tools where you can move different tools out and put other tools in. Instead of using Node Exporter, you could write your own stuff. You could have there's things that are exporters for black boxes. There are push tools that can be used. There's all kinds of things that you can do to get data into Prometheus. And there's reasons why we typically pull from Prometheus and don't push to it. And that's a different concept, but that comes from a different talk that I have. But loose coupling is just this idea that everything's separated out. So if one component wants to change, we don't affect the other components directly, right? That kind of thing. And then I said, what is the advantage given and why you might want to implement this type of tooling? And then I said, do you agree? Why or why not? Maybe you've used some of these other tools and you're familiar with it and you're like, hey, SolarWinds is the big old beast, but SolarWinds is good. And then, but then we talk about why it, got compromised a few years back and compromised a whole bunch of government U.S. government stuff for sure. So anyways, there's reasons why you may or may not agree with this, and I'm fine with all of that. This is your discussion to think about. And then I said they mentioned exposing metrics. What does it mean to expose a metric, and what does that kind of look like in a system? All right, and why does that? So what does it mean, and what happens to metrics that are exposed but never collected? So that's something to think about. All right, so we come down here, and then the second question is your HPC, that's your high performance compute team, is asking about more information about how CPU 0 is behaving on a set of your servers. So your team has Node Exporter writing out to Prometheus, and here's a little simulation. If you guys have never seen this, I'll link this here. This is a great tool. Skip verification. Let's pull this up here. We'll put it right here. Yep, get rid of that. And this is a tool that if you go and you drop in here, it'll drop you right into a Prometheus instance. And you can go see this machine has 4 CPUs, so CPU 0 through CPU 3. And now you've got to go answer some questions for your team, right? And what your team's asking is, can you see the CPU usage of CPU 0 and what does that query look like? So now you've got to go back to this tool over here, and you've got to go figure out, how can I see just CPU 0? So this gives me just that little part there. Maybe I pull this off and I just look at CPU 0 and I go, okay, there's all my information about just CPU 0. So the point of this, the point of me showing you, did I link that? I didn't link that, sorry. Here's the link for people that want it. I'll link it over on the Twitch side and on the YouTube side. There you go. So you've got a tool now if you don't have your own Prometheus. If you have your own Prometheus, feel free to go do this in your own Prometheus, but this is a really good little cheat sheet that drops you in and shows you how to use Prometheus. I love this PromLabs stuff. I've never bought anything from them, but we might maybe sponsor some people that want to go through their course from the Professional Linux Users Group. I'll probably work something out with people that want to do that. But then we have some questions. Can you see this usage of CPU 0 for just the last 5 minutes? And what does that query look like? So in your discussion posts, you'll be working with, if you come down our Discord and do the discussion post, you're basically, nobody's posted on any of these ones yet, but what you're doing is you're coming in here and you're answering, and then you're discussing with the other people in the course. And there's discussion posts all the way back for the last 11 weeks, right? So that's something to think about as you're thinking about, do I want to do the course? It's free. It's just up in our Discord. All you got to do is start doing it. Most people have, we had about 208 people start total, maybe even a little more now because the system wiped. But we probably have about 5 people taking it seriously right now and still going through it. So feel free to hop in if you want. There's a bunch of discussions and terminology that I think are interesting. You should know what a service level objective, a service level agreement, and a service level indicator are. You should know what a key performance indicator is, so you should be able to look those up. We've talked about those extensively throughout the course, so you already know that. What is a span? What is a trace? What is a Prometheus? What's a node exporter? What's Grafana? Dashboard, heads-up display? Just some terminology for you guys to get to thinking about stuff, right? We're going to talk about a lot of that. Then there's the lab assignment that we'll do. You should continue working on your project guide. And then there's some digging deeper stuff. So the digging deeper is always optional, and it's just more things to get you thinking about. Like if you blow through all this and then it's super easy and you go, well, I need more. Well, here we go. It's you can go read the rest of that book and find anything, that one chapter, find anything else that comes interesting about monitoring. And then I say go look up the ProLUG Prometheus Certified Associate Prep. So we put together a prep guide for people that wanted to get their Prometheus Certified Associate, and go find that. It looks like this. It's in the Discord under the resources presentations, and it looks like this. And it's a whole study guide on everything to do with getting your Prometheus Certified Associate. So if you wanted to go through and study, I've kind of squeezed it all down into the things that you need to go do. And then at the end, it's like stuff to read. There's the training, there's the cheat sheet, there's a bunch of functions that you can go look at, and then how to build it, how to use Killer Coda for free labs, and how to deploy it in your home lab, right? So there's all this stuff for the creation of and getting ready for this certification, which is the Prometheus Certified Associate, right? All right. So there's that. And I have a monitoring deep dive that we did a while back. And it's a project that deals with a lot of these same things. And we have a YouTube video on it. And it's just if you want to go even deeper into some of this stuff and ask yourselves questions. And this is what it kind of looks like, right? It's some quotes from Edwards Deming and Peter Drucker and then Dutch, right? If it bleeds, then we can kill it. And we talked about these labs, and then we worked through these labs. So there's a whole bunch of stuff on this. If it bleeds data, we can monitor it, right? Hey, Kolkus, how's it going? Here's our base lab diagram, and this is that loosely coupled architecture where here's the presentation piece, here's the aggregation piece, and here's the data collection piece, right? And we talked about this, and then we go through that. So that's something to go dig deeper. And again, that's more of like if you want to get into the deep engineering part of it, whereas this course is focusing on the Linux systems administration stuff. All right. You always have reflection questions. These are for you. These are kind of like your own journal. What questions do you still have? Like what's unclear? And then how would you apply this to your current role? And if you're not in IT, how can you look to put something onto this resume or portfolio? And I was thinking today when we get done recording this, I'll just roll right into, maybe we'll go look at some job stuff. So I think that would be good. Like look up Linux monitoring and see what kind of stuff pops up. So, all right. So that's kind of that part. Let's go look at the lab for this week. The lab for this week is very simple. I kept it very simple. And it looks like this. All you need to do is run through each of these labs in Killer Coda. We've done the labs before many times. I'm going to actually probably work on them today to show you guys some stuff. And then I said, while completing each lab, think about the following. How does it tie into the diagram below, what you're doing? And then what could you improve or what would you change based on your previous administration experience? So people have been following along with the course. You've got 10 weeks now of experience looking at systems and keeping systems up and running systems. So how would you do some of these pieces here and maybe make them better? And it's not going to hurt my feelings, guys. Like, it's not like, oh, you take apart Scott's course and he gets all mad. No. The goal of this is for you, because once you understand a thing, that's when you can start to change pieces of it, right? Or when you change a piece successfully and the thing still works, but it now does what you want, I really think that's when you start to master it, right? Just following along with labs and stuff and just going through a 16-week course and at the end being like, oh, I learned some stuff, that's okay. But once you start to learn how to like tweak things and move stuff around, you're starting to get like that engineering and hacking mindset, right, where we figure things out. So, and then the conclusion this one is, I say, in the end, monitoring is more art than engineering. This is 100% true. Sure, we can design all types of systems to track the things, but there's no equation or one right answer for any of this. So I always give you guys that separation. If I can give you an equation and you apply that equation to a problem and 100% of the time it's right, that's engineering. If, however, I go, well, it's a little splash of this and a little splash of that, and you cook it up real nice into a dashboard, and it does, and and it's gotta be the things you want. Well, that's different. I can't give you an equation for what's the best way to show some things. We're going to look at some dashboards here, and I'm going to have you guys think through what you think are good and bad about them. What are they trying to show you? What are you trying to learn? All that kind of stuff. So we'll do that. And any of you guys that were here last night when we did, because we always do the meeting on Saturday nights, and we talk about these things first before I record them, so that you guys can be a little more candid about it. But now I'm gonna do it here, and we're gonna go through it live. So all right. So that's all the parts about this week. So let's go talk about all the topics, right? So here's what we're talking about today: what we monitor, how we monitor it, how we present the data to others. Because as an administrator, I want to see certain things with the goal being keeping the system up. Keeping the system kind of, it's almost like one of those, if you remember like the old, like, what was that game, Spy Hunter. And you're like driving through the streets and you're dodging cars and you're shooting everything. So it's kind of like we're trying to keep the system running and avoid obstacles as well. So what we build and what we do the dashboards for are going to be different based on what I want to see. I want to keep my system active and live right now. But what does management want to see? Management doesn't care about being down in the trenches. Management wants to back out and look at utilization of the system for the last 30 days or 90 days. They want to see a trend line going up saying that there's more utilization, so that and there's more users on the system. Maybe we went from 2,000 to 4,000, so that they can request more in their budgets. That's the kind of things management wants to see. I want to see how the system's behaving now and how high is my utilization going versus my saturation. Is anything spiking? And what does the network operations team want to see? Network operations is different. They're not management, but they're not us down in the trenches, but they want to be alerted. So typically they see like heads up dashboards or just alert displays where things will pop up in their faces if something's wrong, and then they can alert out to other teams. So they just want to see what's called a dashboard. Think about the dashboard on your car, right? Dashboard on your car tells you how fast you're going, right? It's got a little thing like this, and sometimes it's numbers nowadays. But then there's little lights on your dashboard, and the lights are off until they're on. And when they're on, then it's like time to go do something with your car. You hook it up and you get the little error code and you find out, oh shoot, it's just my air filter is triggering, and then you can reset your air filter. Or, oh, my oil. My truck loves to tell me that my oil is bad or going bad when I've only driven like 1,000 miles on my truck. It's because I barely drive. I've had my truck for over 6 years now, and I don't even have 60,000 miles on it yet. Because I was working. Even before COVID hit, I was kind of working from home or only a couple miles from home. Like I had found work like near me, so I didn't really have to drive very far. Anyway, but I want you guys to think about like what do you want to show people, right? What do you want them to see? All right, so intro to monitoring. This comes into some of the other stuff. What are the data types that we want to monitor? We want logs. We want to know what's happening in our system, and logs are an immutable record of events happening in our system. Logs should not be changed. Sometimes people like to get logs and then use tools to like transform and like grok or understand events. We call that grokking, right? Understanding events that are coming in and then doing other stuff. That's perfectly fine. But the original log itself, as it moves through the pipeline and down into storage, should never be changed. And your logs, as you store them, you typically checksum them and store that checksum and that log separate, so that if anybody ever changes your logs, you know that something's changed via the checksum. Or if somebody comes to audit your logs, this thing's like shaking a whole bunch. If somebody comes to audit your logs, you want them to be able to validate with the checksum that nothing's changed, right? So that's an important thing about logs. And then there's metrics. Metrics are numerical assessments of a system or application. We're using 60% of our memory. We're using 3 gigs of a 6 gig system, so we're using approximately 50%. And sometimes you have to, with metrics, sometimes you have to compute what it is, and sometimes you actually just get it depending on how you're collecting the metric. So like CPU is sometimes like, hey, it's 99% idle. Okay, that's fine. But then also sometimes it'll be like the system is, not actually doing any weight, and then you have to consider the weight versus like the number of processors and those kind of things. So metrics are sometimes called telemetry. You'll hear them called telemetry. Telemetry just means metrics at a distance. It's telemetrics, right? It's metrics at a distance. So when you hear people talk about I'm getting telemetry data, they're talking about collecting metric data from systems that are in disparate locations all over. A lot of times you'll see telemetry data a lot from when people talk about IOC, IoT, Internet of Things, right? So in Internet of Things, a lot of times they'll be like, I'm collecting telemetry data from all of my sensors or whatever, and that's what IoT does a lot. IoT can also interact with things, but it's often used like in industrial to gather like, hey, a fence was opened. Why was a fence opened out in that some remote location, that kind of stuff. Or, hey, there was a loss of pressure along the pipeline, but we're not seeing it further down. Is there something happening in that part of it? So there's all kinds of stuff like that they do. And then traces is how data, that should be R, moving through your system. And checkpoints and processing as data moves between nodes. So traces will be, you look at a system and in a 3-tier or in a fully, a 3-tier app, you've got your front-end web or presentation tier, you've got your middle application or logic tier, and then you've got your back-end database or data tier, right? And as data comes in and flows from like somebody hitting the web to the application to going into a shopping cart to then doing some MySQL transactions back against your OLTP, online transaction processing database, and then they're doing whatever they're doing in the database, and then the transactions being maybe stored in like a Redis cache or something. All these things are happening, right? A trace is, can we track that whole thing as it moves through all those different systems? And traces are by far the hardest ones to track, but you can do it if you're monitoring your stuff correctly. All right. So anyway, so we're doing all that. From a systems administrator standpoint, what do I care about? As I look at a system, I look at utilization, saturation, and errors. And these all tie directly back to these. Utilization is always 0 to 100% of how used the system is. System has, 120 gigs of RAM in it. Well, if I'm only using 120 gigs of RAM, I am not at 100%, 120 out of 128 is not 100% utilization. Saturation is when I hit that 100% and there starts to be a queue or a line that forms waiting for more resources. I am using 128 gigs of RAM. It's a database that's slurping it all up, and now I'm trying to get another 4 gigs of RAM to do something. It's not going to work. You're saturated. Things are now starting to form a line in queue. And as they form a line, they start to hit timeouts. Maybe their API calls trying to do something. Maybe their SQL transactions that are now waiting. And errors start to happen as, 1, 5, 10-minute timeouts are hit. And errors should always be reported out to logs. And they should be easy to spot. They should be alerted at a different level than other types of errors or other types of logging events, right? And everything in here is easier if you're actively monitoring your system. I've shown you guys this before. Like, I can come in here and I can check all of these systems like this. This was actually me running this yesterday. I can show you guys, oh yeah, look, all the servers are up. Nobody's on any of them. These are all the lab servers you guys have. Nobody's on them. They've been hanging out. They're chilling. They're all real low utilization over here. Nothing's going on. But I could also SSH to Rocky 1 and do like a tail-F on like varlog messages. And we could watch to see if anything cool's going on in here. There's literally nothing going on in this server. Nothing has happened since the system D came up. So, knowing that, well, that's cool. Okay, hold on. Let's go. All right, look at that. Varlog messages. So, you might very quickly say, "Well, Scott, that's silly. You got 19 of those damn servers to go through. And you're just going to go log into each one and look at them?" I'd go, "Yeah, that's not very useful. That's not very good use of my time, is it?" And could I do that better than a system could? Absolutely not. But what if I did this? What if I had something like in my home lab here? Let's go here. This is going to be bright for a second. Sorry, guys. That was our stuff that I showed you earlier. And what if I came here and I said logs, and we just went to my Loki dashboard. And now on my Loki dashboard, I just go to like messages here, and maybe I just say Rocky. You know, here's all my Rocky boxes. And now right here, I can just see all of my Rocky systems and messages right here. So this might be a much easier way for me to maybe look at everything that's happening in my system. And anything that's happening, so there's some garbage collection. There's some K3s sitting on Rocky 16. So somebody's been in Rocky 16. Let's go look at where's Rocky 16 at over here. Some user's been on Rocky 16 and put Kubernetes K3s on it. And there's some garbage collection processing. 16 and 17 both have it happening. So, now I'm seeing all kinds of stuff. And it looks like some CPU stuff just happened across all my systems. But the point is, I can look at everything here. I can see kind of everything that's going on in my system. Excuse me. So that's a better way for me to look at logs. All right. So let's go look at tracing and spans. So there's tracing and spans. And the idea, this comes directly from Grafana Labs. A trace is where we can look at the whole journey of a request or an action as it moves through, like I was mentioning. So multiple different things happening on multiple different systems. And if we have proper monitoring, not monitoring, but metrics labeling in Prometheus, we can do this very easily. And then spans are a set of times. So maybe I want to look at something that was happening from midnight to 2 a.m. across all my servers, and that's more of a span. But a trace is an individual thing. Hold on, let me see this. New to your channel and started working on labs. Just reached the Grafana Monitoring Labs. Thank you for sharing these resources. Nice. Yeah, we're going to do some of the Grafana Labs right now, too. So hopefully that stuff's useful to you. So this is tracing and spans, right? And then here's monitoring architecture with a tool. This is just a tool. It's just part of that other stuff we were showing. And Prometheus is a very popular one. So if you were like, Scott, I want to get into monitoring, but I don't want to be, I've heard Nagios is on its way out, and I heard Zabbix is kind of a cool newer version of monitoring, but it still uses Nagios as its core. And I say those things are still there. They exist. There's some value in them. But if you said, Scott, I need to know the most value for my time. My time's super valuable. I'm spending 60 hours a week on World of Warcraft, and I need to spend the last 2 hours a week I have on learning something. And I say, okay, fair enough. I'm not going to tell you not to play your video games. But I am going to tell you I'm going to tell you that Linux Linux is most important, but Prometheus is a really good tool to go learn about. Yeah, Prometheus is the newer thing, yeah. Newer, but it's also a loosely coupled architecture where it can sit between a bunch of different types. This doesn't have to be Node Exporter. We use Node Exporter in the lab, and I show you how to do that. But there are so many things that Prometheus can pull data from. And at the end of the day, after it retrieves data, it just throws it in a time series database. Time series databases are optimized on time. So it's very easy to get spans of time. Atticus Now over on YouTube, how's it going? We're just recording Unit 11, so if people missed it yesterday in the group, it's some way to come in and look through stuff. There's service discovery. If you're using tools like Kubernetes and Console, we can send out alerts. We can query the data. So you guys that are using that link that I sent earlier about where you go in and you do the Prom Labs cheat sheet, you're using a web UI. But you can also use Grafana to query data out of there. So there's that HTTP front-end web server. Excuse me. And then the time series database does its own data collection, and it can forward samples of data, and it can also aggregate down to what we call a lower resolution of data, but it can keep data for 30, 60, 90 days. The default, I think, is only 14 days by default, but you can change all of this stuff. All right, so let's go look at this. Why do we care about this stuff as administrator? We're the people running the systems, right? But the reason I tell you as an administrator we care about monitoring is because good visibility in the system is the number one thing we can do to predict or prevent errors. So that's very important for us to, all the problems that we've had earlier, if you go back through the old, so you're looking at this and going monitoring, and then you go and look back through the problems that I had us do from the 10 weeks back to week 1, and there was always some kind of problem happening in your system. Almost every one of those problems, you would go, that was easier if we were monitoring. Monitoring does one thing very importantly, as I described that's a technical term called MTTD. MTTD is your mean time to detect a problem. And the shorter, so if you look at, like, this is an incident right here. This is an incident happening in your environment. This is when the incident starts to happen, and this over here is when the incident's resolved. Well, if this is when the incident starts, your mean time to detect is just a critical path item that starts to happen. And once you've detected it, now you start to fix it, mean time to repair or mean time to resolve, MTTR. And then let's say your mean time to resolve a problem is 15 minutes. So this right here. But then when you do your after action review, it took 6 hours to solve the problem. Took 6 hours. But 15 minutes was your resolution. And 5 hours and 45 minutes was the time it took you to detect that there was a problem in your environment. I can guarantee you if that happens, management's going to look at that and go, what the heck and heck? And they're not going to say heck. They're gonna be pissed. Because the fix was routine. It was 15 minutes. 15 minutes, and I was sitting here sucking down a soda or a Monster while my system fixed it in 15 minutes, my little script I had. But until you alerted me to kick off my script to fix it, that took 5 hours and 45 minutes. I guarantee you that doesn't happen often before heads start to roll in the environment. That's bad. That's bad. Especially if that 6 hours is customer facing and you're losing real money. You got to get your mean time to detect down, MTTD. And then that shortens your mean time to resolve. Because when I say a term, that's a technical term, a critical path. The critical path is time that cannot be shortened along the path of a objective or a outcome, right? All right, anyways, that's engineering stuff. But and we're going to do an engineering course after the new year. I'm going to take a little break after all this, and because I've got a lot of work with my dissertation and stuff. But we have to have our own view of the system. What do I want to see? I want to see the uptime. I want to know that the servers are working. And then I said, we often have to provide views for people that have different goals. Management wants to look at, like, the system holistically. They want to see that this happens a lot in high-performance compute. We've got a cluster of 3,000 nodes. And those 3,000 nodes, 2,500 of those nodes were operational the entire time, and 500 of those nodes were in some other state. Well, I'm going to tell you right now, if you're operating at that kind of ratio, you are probably going to get told, why are 500 of them out of commission? Why are 500 of them, for whatever reason, not up? Because that's a 16 and some change % of your overall processing. That's a lot. So then your goal is to figure things out and drive that down. So now next time management sees it, it's 2,600 that are always up and only 400 that are down. And you keep driving that through whatever methods and whatever tooling you're doing to get down to only having, maybe it's acceptable. It's actually pretty acceptable in a 3,000 node cluster to have 100 nodes in some other state. I mean, we have MTBFs, which are mean time between failures. We expect disks to fail. We expect network links to fail on that many nodes, but we need to be able to understand these things and track them, right? So management wants to look at that. Our monitoring teams, which are like what we call sometimes our 24/7 support, they're network operation centers and security operation centers. There's different names for them. They want to see alerts. They want to see a dashboard light turn on that says there is a problem. then that may trigger them to go and do some checks, and then those checks would immediately say it's either good or it's bad, and then like these are quick checks, and then if it is bad, they need to call somebody out. If they did that, then we would only have 15 minutes, maybe 20 minutes of mean time to detect that there really is an error. And then they contacted me, and it took me 15 minutes to fix the problem because I had seen it before. And now that was 30 minutes to solve a problem. That is much more acceptable to a company. And then you might say, man, my company pushed it even further down. Yeah, some of the big companies, they're pushing that down into the minutes and seconds. So that time is getting shorter and shorter, but you have to have a good procedure around it. Which, by the way, is one of the reasons I'm always telling you guys about those site reliability engineering books. Those books are good. Riven, you said, hello, quick question, is growth part? I've never heard of GrowParth. I don't know what that is. But I can tell you this, growing partitions is always safer than shrinking them. But that's just from 20 plus years of doing this. All right. So I want to show you guys some dashboards, right? We're going to look at some dashboards, and I just want you to think about these, and you guys can respond here, or you can just think about them on your own. But what do you think they're trying to convey? I'm not going to tell you anything about these dashboards. We're just going to go look at them, and then we'll talk to them, and look at them. And then what's good about them, and what's a weakness? So what are they trying to convey? What's good about them, and what's a weakness? Let's go look at the first one here. Let's see if it pops up in the right spot over here. Nope, popped up in the wrong spot. All right. So here's a dashboard. All right. I'll put it here. All right. Here's a dashboard. Just some dashboard. And we'll zoom in on it a little bit. And what do you think it's trying to convey? It's got a name up here. That might help. What's it trying to convey? And what's good about it? What do you think is good? And what do you think is maybe a weakness of it? And obviously there's different contexts too. Like, is it for management? Is it for the NOC? Is it for us? But I want you to look at it and think, like, what is it trying to teach me? What is it trying to show me? And then what are some good and bad things about it? This is the dashboard right here. Those might be kind of useful for us to monitor. What do you guys think is good, bad, indifferent about this dashboard? All right. So I think you guys probably know what it's doing by now. It's core DNS, right? And then what's good about it, I think it's got pretty good graphs. I like the graphs. I think those would be good if I needed to go kind of dig in what's happening in my environment. But one of the downsides to this one, whatever else is good or bad about it, is I would not show this to I might show this, but I would not show this to like a network operations team or something. This is not good as a heads-up display. And why is it not good as a heads-up display? Because I got to scroll up and down through it. If I'm doing something that's a heads-up display, what people sometimes call HUDs, they need to be, boom, just like this. They need to be one page. Everything needs to fit on that page, and they need to just be green if they're good and probably turn red. So this right here might be really good to show my team and say, hey, if this upstream check fails right here, this upstream health check ever gets to 10, and 10 is where it turns red, then alert us out during the working day. If it's at night, just leave it, and if it persists for more than 2 hours, maybe I don't know, something like that. Like you can write whatever you want into your procedures. But my point is, there are things that may be useful to see here, right? All right, let's go look at another one. So this next one is, let's see if this next one's any good. So what's this one trying to do? This one's very short, and it is a image that I think people yesterday, when we were talking about this yesterday, I think they liked this one, or you might not like it. But what is it trying to show us? is it a good dashboard or is it a bad one for different views and for different reasons? So I want you guys to think about that, right? This is the internal quiz time. You're taking your own little quiz here. Anybody here know what those response codes mean? What's a response code of 200 or 400? Is it bad that they're not showing 300s and 500s? Does anybody know what the 300s and 500s are? I mean, that's a different discipline of engineering, but it's an important one if you're, even though maybe we're Linux systems administrators and maybe we're building monitoring out for our thing, but why do I need to know what those codes mean? What I've showed you guys this before, talked about this before, but why does it matter if I know the response codes to something? I'm not a front end or a back end developer. Why the hell do I need to know those codes? They're still passing through our systems, guys. They're still passing over our systems, right? And we can track them. We can track what's happening inside that app, right? So this obviously Nginx says up at the top there, but 200s are any kind of good responses, and then 400 responses are when the client has an error, right? 400, yeah, they're web server status codes, exactly. They're very well defined. There's some actually really good little funny quips about them online you can find if you guys want to study them. But you should know at a high level as an admin and an engineer like what the response codes are. 200 is always good in some way. There's different types of 200 codes, but 200 itself is good. And then 400s are clients are doing bad things. And clients may be scanning you. This could be right here. This is a bunch of 404 responses for bad paths that people are trying to pass in. Glam Shatter Scroll. Yeah, 503. So I'll show you guys where you can find them. So Wikipedia, status codes, web, right? So status codes. And 503 should be, if we come down here, there's a whole bunch of them. And 503 is right here. Service unavailable. But one of my favorite ones is this one. 418, I'm a teapot. I can't meet the requirements because I'm simply a teapot. Yeah. 400, clear your cat. Yeah, there's a whole bunch of them, but 400s are client errors, so you made a bad request. 500s are server errors. You don't want to give all your server errors outside of your organization typically, so because that could give somebody ideas about what type of services you're using, what your backend looks like, what it means for your system to be overloaded. There's a bunch of things, a bunch of reasons not to show 500 errors outside of your organization. But the point is, we can see here that there's a bunch of good responses and a bunch of bad ones, but they almost look like somebody's probing us. But I asked the guys this. Could a spike in 200, which are good responses, still indicate that we are under attack of some way? The answer to that's yes. Somebody can still be ramping up a scanning tool against your system to try to see if your system cannot handle so many good responses. It's not always about handling bad responses. In fact, most of your good networking devices, most of your devices that are doing any kind of active web application firewalls, they start seeing a lot of this come in. They just shut off traffic to your web server, and your web server doesn't experience any load. It just fucking cuts them off. It's like, you guys want to do ratchet shit? Go do it somewhere else. And they don't even let it get to they treat the web server like their little brother, and they just they're like that meme where the guy's standing with all the armor over the little guy with his sword, and they're protecting him. That's what web application firewalls do. They see stuff coming and they block it from stopping your web server from normal function, right? Anyways, my point is that's not any of this stuff, but this is a very useful heads-up display to see what's going on in your system. So I might have this just be on you know how I have my little rotator tabs or revolver tabs and it just revolves through things? I might have this up. If my company did a lot of web tooling, and we did a lot of web page maybe, and maybe our Nginx was our front end that was, maybe it's even just acting as a proxy, a reverse proxy to a bunch of applications. This may be something I show my dashboard, and then they can just keep an eye on it. It's a 1 hour window. It's from 1620 to just past 16 or 1720. It's a 1 hour window, and they can just look for anomalies. That's all. Just a heads up display. See what's going on. All right. So that's something to think about. Let's go look at this next one. This one is, what's this one trying to show you? Also, I could link these to you guys if you want them, but I don't think anybody cares that much. Here's this. These are just images off of the Grafana website, by the way. But what is this showing, and why might we want to watch this? And then, what are the good things about it, and what are the bad things about it? A little bit of a thinking, a little bit of almost like a little self-quiz. What is this doing for me? What is this showing as far as averages and maximums? Is it bad that over here we're getting hit really hard? Did something change, right? This is AWS Lambda function, so that's serverless execution of functions, right? And guys, I know there's a server somewhere, but you don't have to worry about it. That's why we call it serverless, right? So, in fact, serverless means you don't need a guy like me running your servers, right? That's exactly what that means. But now, yeah, you've got really low duration and many invocations, and then you have less invocations, but they're taking longer. Maybe this right here is when you opened it up to actual web traffic, and it's no longer just little, you were doing some light testing over here, and then now real users are actually doing queries, and it's taking longer in your backend Lambda functions. That would be useful to know, because you might have done all your calculations based on this load over here, and now the load looks like this. For 1/3 the applications of calls, you're getting 4 times the amount of work that you expected were coming. So now you got to rework all your back end, what you expected and what your costs are going to be, and all that kind of stuff, right? If you're doing engineering, anyways. So, all right, something to think about. Let's go to one more. Let's do one last one. This one is, what is this one trying to show you? I'm not even going to zoom in on this one too much. We'll just zoom into here. What is this one trying to show you? Do you think this one's good? And what's bad about it? Actually, well, I'm not going to say anything about it yet, but I want you guys to look at this. What's it trying to show you? I picked this one specifically because we just got off of a containers and a Kubernetes, so I wanted you guys to see something that dealt with that. But what's it trying to show you? What's good about it? What's a weakness of it? Let you guys think about that. All right, so it's showing us Kubernetes. It's a full Kubernetes system. It shows us how the overall usage is going of our different nodes. It shows us how the nodes are doing as far as this over here is their network traffic in and out, right? The average memory use. But a weakness of this that was pointed out yesterday was you can't see everything, but maybe this is just enough to help you get ready to dig down in there. I do like the color coding. I'm colorblind, but I can tell what's green here and what's red, reddish, and then what's good or bad. That's kind of useful. You can also see very quickly that you're looking at all of what's being monitored. Maybe if you had some different environments, you might skip down through your different environments. But all in all, this is a pretty good heads-up display, especially if these ones turn red when they go into some kind of critical event. And then now we could know, for capacity planning in the future, management could look at how many times over a month maybe that this went red, or what we went to call resource exhaustion, and then they could start to plan, hey, we need to add a few more nodes to that cluster, and then that drops the overall usage down, and then we don't see as much red, right? that kind of stuff. So we can keep track of that. And I think that those are all pretty good ways to kind of look at this. All right. Here's another one. I have one more. This one's kind of busy, but this one is also a node exporter for one specific host. So this is one host. It's node 01 in an environment. And I want you to think, is that good, bad? Does it give you a nice little heads-up display of what's going on that one node? And I think that's actually pretty good. Because this wouldn't be something that I would show. Like if I had 3,000 nodes again, this would not be something I would show to the NOC, because that's one node. What am I going to do? Flip through all 3,000 of them? This is more of a something's happened, and now Scott here has to go and look at whatever's going on. W equals VA over on YouTube said, how much oversubscription do you use in Kates? I don't really use any in my home lab stuff. But my brother was here talking last week, and he runs Kubernetes. He runs OpenShift for a really big insurance company, one of the 5 biggest in the U.S. in fact. And he runs all their Kubernetes and stuff. And his overcommitment that he was showing was about 600%. So, or his oversubscription rather, in that case. And he said his stuff's just chilling. He was showing his stuff just relaxing, even at 600% oversubscription. So. But yeah, you could. We didn't record his presentation, but if you want to ask him about it, just ask him down in the Discord. He'll tell you all about it. And that was my brother who came and talked to you guys last weekend, if you were around for that. All right. So here's our lab task this week. You're going to go build out the labs in Killer Coda, build out a prom tail to Loki to Grafana, and think about what you're actually building. This is like more of like if you want to kind of dig in and look at some of the stuff. Then Telegraph to InfluxDB to Grafana, and then Node Exporter to Prometheus to Grafana. So then there's that, and then if you've got questions, you can message me. Let me pull up the... Where is my... I think I have it right here, yeah. So, okay, so let's get out of here. That's my home Rocky environment, right? That's my home, we're looking at the Loki labs in here. And here's our PromQL cheat sheet again. But let's go over here, and the first lab, if you go look in the Het Tanis labs. By the way, all this stuff's free on Killer Coda. They never charge you for anything. But the first setup here is you want to build a tool that is going to do your monitoring for you. So we'll do it like this. Then we'll say 8 so you guys can see. And it says right here, your team has determined they need to offload and monitor logs in your environment. You don't want Linux logs on a Linux server longer than it takes to generate them. You want them sent off in real time. We've talked about why that is, but it's because it's one of the major ways that people cover their tracks as any type of nefarious actors, is they wipe your logs. Well, if your logs are going off in real time, that becomes a ineffective method of stopping people from seeing what's going on. By the time they've connected and even managed to establish a connection, you already have a record of it. Then anything that they do and anything they install and anything that changes anything in the system is already being sent off in real time before they can go back and delete it. So that's an important thing to understand. On top of the fact that logs should be immutable. So you know that Grafana can do what you want as a visualization tool, so you're going to deploy Grafana on one of your nodes. So it says here, deploy Grafana, ensure that it's running on your server. So here's how we deploy Grafana. We can go look at the information about how to install it. There's a bunch of info there. But even before I do that, I can, well, again, on the side, you can go read that as much as you want. Let's install a couple of dependencies. There's some transport HTTPS and then some software properties and wget. Just make sure all that stuff's there. And then we're going to use wget to download the Grafana key from Grafana. It's the GPG key, and it's going to go into our keyring so that we trust things that are signed by that. And here's how we create that trust inside of a repository. So we just build a little repository. We echo this into this file. So now in this file right here, if I were just to go more of that file, we would see that anything signed by user share keyrings grafana.key that I get from apt.grafana.com stable or main as the two repository tags that we'll use, we can download. So now I'm going to update the system and get all the it's going to update all the metadata, and then I'm going to install Grafana Enterprise to the system. It's going to install it. It's going to go put it in all the places it needs to in systemd and all these other things that it needs to do. And then one of the things we're going to do is we'll do the system daemon reload, even though it's already been done. We'll start Grafana and we'll go look and see that it's running, right? So we'll go grab this. Boom. Right. So this will be our lab. Real quick, we're going to restart the service and we're going to see that it's running, and then we're going to go look, and while we see the process running, we don't see it listening yet. It takes about 10 seconds for Grafana to kind of, it's like an old Buick. It's got to sit there and idle for a while and warm up. It doesn't really have to do all that, but it takes a little while the first run. And then now we'll see Grafana running in our system. It's listening on port 3000. We've got an instance of Grafana running in the lab. So there's a bunch of questions you can ask and think about as you're doing this, but now you'll have, in your lab, you'll have a different link than me here, and it will bring you to your instance of Grafana. And your first login to your own Grafana is admin. So we'll let Grafana come up here, and we'll connect in on admin. We're not going to let it save the password. We're not going to worry. And then the password that we're going to pick is 1234567 1234567 Very secure, very secure password change, right? And now we're in Grafana on a brand new instance that we just built. Don't worry about saving it. All right. So we come down here, change your password, and then we're going to go over, and the next piece is going to do, we're going to use a log aggregator tool called Loki. So Loki is an API that'll sit in your environment, and you can just chuck data at it and pull data out of it as logs. You can secure it with certificates, but we're not really too worried about that right now. You can, if you're doing like zero trust principles, you can have it only talk to devices and only listen for devices that have the right certificates. But we're not worried about that now. I'll probably do that in a future lab. But for now, we're just going to make a directory, opt Loki. Opt is where I like to store things that are going to be our like third-party tools and stuff. Opt is just a common place that a lot of Linux engineers put things. I'm going to cd into opt Loki, and I'm going to download the zip, unzip it, and run it. Once we do that, we're going to copy in a local config file that I've saved, and we've had to update this a few times because they keep changing their damn local configs. And then we're going to copy in a service file and do a system daemon reload, and then we'll go look at the general config. Here's the general config file for Loki. What are the things I had to take out? I had to take out this because they've changed it recently. We had to pull out this because they changed that recently. But I want to show you guys this. This is one of the things that actually bugs me. Is right here. It says, by default, Loki will send anonymous, uniquely enabled information. And if you want to disable that reporting, uncomment the following line. So I've uncommented it in this lab. But I want to let you guys know that it's typically commented out, but it's not the default standard, and that's not the way that we normally do things. Normally, if that defaults to true, that would be commented out, and we would say true there. So for me, and you can take this however you want, especially if you're somebody who supports Loki, that's a dishonest way to run your open source tool. To put in, because this is normally commented out and it says false, but that's not the default value. And they know what they're doing. They're defaulting people to yes and not telling them. But anyways, the point is most organizations are not going to want to send their data out of their organization. That's a big no-no in the corporate world. No security team on planet Earth will let you do that. Well, no security team worth their salt. There's a whole bunch of them that are terrible, but they're not going to let you send data out like that. Anyway, so let's see if it'll start, or if it errors. It should, yep, so it did start. And then we'll go look, and we'll see that Loki's running and listening on port 3100. So we've got the Grafana piece. We've got the Loki piece. Now we got to start throwing data at it to make it all work. So in your research, you find out that the Promtail tool can push logs over to Loki in real time. It can just launch it up there. Tasks will be deployed to configure PromTail to push Loki to the server. So, your task is to deploy and configure PromTail to push logs into the Loki server. Okay. So let's go do that real quick. So let's make directory opt PromTail and cd in there. And then we're going to pull down a specific version of PromTail and unzip it. And then we're going to copy in a little config that I have, and we're going to go look at it. This config really only changes two things. In the scrape configs, you've got a job called syslog, and that goes and grabs varlog syslog. And then you've got a job called auth, which goes and grabs varlog authlog. If you have any other logs in your system, maybe you've got like a Java process running that writes to a specific log file for app1, you'd put that there, and you would just name it job name, whatever tags you wanted, right? So instead of auth, you would probably say app1, and then your targets would be local, your label would be app1, and then your path would be the path to your app. It's that simple, right? And you could even deploy this as I think an Ansible playbook that deploys all this in one of our other labs too, right? So it's not super difficult to get this working. And then, and get it scraping the right things we want. And it pushes everything over to Loki on port 3100. Loki API v1 push. And it's going to apply the labels as it goes so that then from Loki we can pull the labels, right? So we go ahead and we copy this stuff all over. And then we look at, here's how we start it in systemd. That's our little service file. Super easy to set up a service file. We're going to do a daemon reload. And then we're going to make sure that Prometheus, in this case PromTail, is running to push over to Loki on our system. All right, boom. So now we've set up all the pieces. We've set up the PromTail to push to Loki. Loki is not yet connected to Grafana, but Grafana is up. Now we're going to go take Grafana and have it give, we're going to put it in as a data source for Loki. And then we're going to look at a dashboard and make sure that we're pulling data out of that system. That's all we're doing here. So we'll connect over to our Grafana. Okay. We're going to go over here and we're going to go to connections. And we're going to say that we want to use Loki, right? I mean, isn't that what we just set up, Loki? We can search for it or we can come down. I just search for it because I'm lazy. There's Loki. And it says right here, when we add the new data source, we're going to use 127.001.3100. So 127.001.3100. There we go. There's no special authentication, but we could use OAuth, or if we wanted to use TLS to have certs. We're not doing any of that stuff. We don't have any additional timeouts or anything like that. It's one of my favorite things about Grafana right here, guys. When I hit save and test, it'll tell me I successfully connected to that data source. One of my favorite things. If there was anything already flowing, we would see it here as well. So we save and test it. That's good. Now we're going to go over to a dashboard, and it says right here to bring down this dashboard. So this is a dashboard from Grafana. It's in there open, like you can download dashboards and import them by name. So I'm going to say, here I can say new. I'm going to go to import, and I'm going to import it by its ID. And I'm going to hit load. And it'll tell me, hey, here's the logs and apps. Its folder will be dashboards, and it uses Loki as the data source, so go ahead and give me Loki. And I'll say, okay, good. There we go. And then now here we've got our auth stuff going on. We've got our syslog stuff going on. And if we wanted to see this in runtime, right, in real time, let's go back to authlog. I show you guys this sometimes. So let's leave this here, and then let's change the refresh to every 10 seconds. Okay, so now this is refreshing every 10 seconds if an event occurs. Let's go back over here. And on this server, let's just say while, let's just do it like this. Let's say for user in backtick seq 100 do echo I am creating user $user, right? And then we'll say user add -m user $user, so it'll be user and then the number, and then sleep maybe 3, done. So it's gonna say I'm creating user 1, I'm doing whatever, and then we'll just sit over here and look. And we'll watch, are the users, you already see one, are the users being created over here, and it's refreshing every 10 seconds, so we should see about 3 or 4 users each time. Are we seeing the users pop up right here? We are. So, what if my company has a policy that new users are never created on a Linux server. So your company might have a policy that looks like this. New users or local users are created on a Linux server only when it's first built and only for applications. All other users that are ever put on a server always come from Active Directory through some kind of trust model like SSSD or identity IDM, identity management. You always have, so that always happens outside of this. Users aren't really created on a system. And then you're sitting here looking at this, or you've got a trigger for an alert on this, and a whole bunch of users are getting created on your machine with bullshit names like this that don't follow your user standards. Is that a problem? Yeah. As an administrator, I would immediately go to this box, kill whatever's causing this, kill whatever user's connected, and probably, depending on if this was non-prod, that box would already be shut off. But if it was prod, I would definitely take this out of whatever rotation I could. Pull it out of a load balancer, do whatever, and go look for whatever I'd pull it off the network and go in through the console. And I would immediately take a copy of it from memory, like snapshot from memory, and that would go over to my security team so they can do their forensic stuff. But then me as a Linux engineer, I would start, an admin, I would stop whatever's doing this and go look at what's happened to that box. See if I can find what the compromise was, see if I can find where the connection came from, all of those things. The old way my company did was export the logs to another file, important log, and send email based on that important log file. Nothing wrong with that, LG, as long as it's getting off the server in real time. See, by the way, if when this is all done, the last thing we did in that loop, like I had a command after the loop that just wiped that log, it wouldn't stop. I would still have a record. Does that make sense? Like, hold on. So I've shown you guys this before, but attack.miter.org. This is where like attacks are kind of defined. Like this is a common attack, what we call a attack matrix, right? It's a very common one. And one of the things that happens over here in discovery is people will try to delete or get rid of logs. It's a very small one. It's just over here out of the way. It's not the log emulation. I think it's... Where's it at? Basically, it's where they wipe their logs. Maybe it's defense evasion. I can never find it. Hold on. Where's that? Hold on. Nope, not that. It's not log enumeration for sure. But anyways, it's like wipe. Where's that? No, it's not disk wipe either. That's impact at the end. All right. Well, anyways, I can't find it, but you guys, I've shown it to you guys before. And my point is that they can't do that anymore. Yeah, LG, if anything's happening, yeah, you want to get, typically you want to get logs off server immediately. You want to get them put somewhere. Our syslog is pretty good still. That's a way to do it, right? Yeah, I would get stuff off the system as much as you can through scripting tools and not have to wait. Look, this thing's still running. This is still generating users on the system that should not be there, right? So anyways, then we come over here and we hit check and it's done. Everything. Look at you learning configurations. You built a Grafana. You configured Loki to catch logs and to feed them into Grafana. Grafana was pulling from there, and then Promtail. And you're seeing it in real time. It's building the users, and then over here, it's showing you in not exactly real time, but it is sending the logs off in real time. This refresh is our limit right here. We're refreshing every 10 seconds. All right. So, if you were tracking, you have done all of the Linux systems administration stuff for this week. We did one of the 3 labs, right? I did it with you guys. We went and we actually verified that we could create users and see that logging activity go all the way through. We could also go watch. I can come over here And we're just looking at auth. I can come over here and I can SSH to, or SU to user. Oh, we made them uppercase. That's terrible. I don't know why I made them uppercase, but user 98. Oh, it was lowercase user, but my bad. All right, so we go on here and now we do a sudo -i, right? And we try to become root, and we just do some bad passwords, bad passwords, bad passwords. And that failed. And then we come over here and it says, oh, there were some problems. Somebody tried to sudo and they weren't in sudoers. That's a problem. You could use that as a trigger. And one of the things I show you guys in some of the other labs, so in that digging deeper section when we were looking at some of the other labs, you could come over here. Let me get rid of this real quick. And let's go to log QL. Here's log QL, and if you go to log QL, there's all the information about how you can query logs, but then you come to their little they've got their little editor, and this will actually help you to query out. Where do they have it? Hold on. Where's he at? Where's our query editor? I don't know why. I don't know why they have this. They've changed this around from the way it used to be. But you used to be able to just go drop right in here and it would give you... Hold on. Let's see if it'll just let us... They used to have an editor right here on the page. I don't see it anymore though. They've definitely changed this page around. Where's it? I want... I don't see. Yeah, they used to have the editor right where you would drop right in it. Ah, here it is. Okay, here it is. Okay, so watch this. I can go get rid of all these, right? And I can drop if I trust that my logs are, you know, I wouldn't be putting my corporate logs in here, guys. That's not the way we do this stuff. But I could come over here and cat var log messages, right? Var log syslog in here. Let's grab all this. Again, guys, I would not be doing this in the corporate world because you're about to grab a whole bunch of your real logs. Don't do that, right? Don't query analyze against real stuff. But messing around here, there's no problem. Whoops! What the hell? I thought I just captured all this. Copy. Boom. All right. And now I get a run a query. I get nothing. There's nothing coming out for that. It's not going to find anything. But I should be able to come in here and do, if I know how to do a simple query, which you can go find your query best practices and you can go look at these and go, okay, this is how I can query things down, right? And they show you how to do it through Grafana, and I can go, okay, contains a string, so it's something equals or does not contain a string or matches a regular expression. And I can go, contains a string. What if I did that equals, like this equals, like NOV, right? And then I run my query. Does that find anything? No, that gives me an error. So then I come back over here and I go, maybe I need to go look at the way it was originally set up, right? And maybe I come back over here, I hit Control X, and then maybe I redo this page, right? And I go, how did they have, oh, so it was something equals this, or message equals this, or file equals that, or it just looks for some pattern. Yeah, we could do that, I guess. Job analyze log format, right? Level equals whatever. I want to look for just unstructured test. and I can just look for, in this case, a pattern, right? And so, guys, there's a whole bunch of things that you can go spend your time on with this if you want to get better at it, right? All right. What's your question? Just one extra question about the logging K8s. How do you deal with these log storage? So K8s a lot of times will have like a sidecar or a separate container inside that we can push over logs to, and then that is always pointed back to like a PVC, and then that's storing data. You can also have your containers always pushing data to a local storage if you wanted to. But the point is, containers themselves and pods, as they are ephemeral, so we don't store anything on them that we want to keep. So you got to think about like what's important and what do you want to see. They can throw data out to Loki as well if you wanted to. You can write that into your app. So there's a whole bunch of ways to do that. Yeah, but I would just treat any logs inside of any container as completely ephemeral. And if I want to store them, I got to have a plan to store them off either through my application or just through like a sidecar that's pulling stuff off in real time. That's what, and I'm pretty sure there's like a Promtail sidecar that you can just run. Pretty sure that's the kind of thing. But anyway, so that lab's done. All this stuff's pretty much done. And we went a little longer. I tried to keep these about an hour, but I threw those up so that you guys could see that. So let's go here. This was the other thing I thought about doing today that I thought would be kind of fun. If we pull this up here and we go to something like dice.com, we'll just go over to dice.com, right? Just some site out there, and we'll look for Linux monitoring. And let's see what people are looking for in the monitoring world. Like if we're looking for jobs, and systems administrator. This is a new one. I haven't looked at this one before. And I'll get rid of that because I don't think you guys need any of that stuff. We didn't really go too deep into that. So let's say system admin. And what kind of monitoring stuff? We're looking specifically at monitoring. They have software development lifecycle, Kubernetes, Jira. So they want you to have some experience. They've got some start dates and end dates. Where's the job at? Where's the job? Show me the job. Full job description. All right. Working for the Arizona State Retirement System. My wife's part of that. So, well, she's not part of working for them, but she could get her Arizona State retirement in 5 years. What do they want you to know? They want you to understand CloudFormation, code commit, and code pipeline. That's heavily AWS, by the way, so they want you to have AWS. They want you to have some software development lifecycle pipelines, so understanding pipelines and probably some CI/CD stuff. They want you to script and automate in languages like PowerShell. That's funny to me that they put PowerShell there when they're talking AWS because, I mean, not that PowerShell can't work with AWS, it's just not it's not even in like the top 5 preferred methods to connect to AWS, but you can. They want you to understand IBM FileNet, never heard of it. Atlassian Jira, we've all heard of Jira. It's just a ticketing tool and way that we do jobs and work. And Kofax, I've heard of Kofax, but I don't know what that is right off. And they want you to know data security, privacy practice laws. Okay, so that's probably some stuff that you need to learn. They want you to have information around Docker containers and Kubernetes. We've been working on that. Linux, we've been working on that. Windows, we haven't been working on that too much. PowerShell and the Azure CLI are 2 different tools that both do similar things. So Azure uses PowerShell and Azure CLI. They want you to understand server environments, and SolarWinds is their network monitoring. So you might say, hey, I don't know SolarWinds, but I have done these other monitoring tools and I understand how to monitor systems. We want to monitor systems for uptime, which is ping checks and maybe service checks. We want to monitor our systems for how much utilization they're having, so how utilized they are between 0 and 100%, for how saturated they are when they're getting over 100%, and there's a line forming in queues, and then we want to also track them for errors that are coming out of them, which are logs and that kind of stuff. And if you told somebody that you use that use method, utilization, saturation, and errors, I'm always hammering that utilization, right? Use, utilization, saturation errors. It's the use method of monitoring systems. Utilization saturation errors. If you explain things like that, people are like, ooh, I didn't even know about the use method. Oh, that's pretty good. Right? And then now, if you ever teach somebody something in an interview, even accidentally, they're like, ooh, this person's at least been around the block once or twice, right? So anyways, so there's that. Work flexible hours, Monday through Friday, 8 to 5. That's pretty reasonable. Temporary, 6 to 9 months. But typically, if you're doing good, they'll hire you on. That's how a lot of these are. So that's what they want in that role. So you might need to shore up your AWS a little bit if you don't feel very good about that. You might have to look up some of the AWS pipelines, which are not going to be SDLC. They're going to be more CI/CD, but that's, they're just using an older term there. If I had to guess, this job was posted and somebody modified an older position to make it work for like a new one. This role involves 75% people management, leadership, and 25% hands-on work. So this is systems administrator, but you're managing people. So I'm out for that one. I ain't managing nobody because I'll just fire everybody. That's one of my red flags. Like, I know I don't need to be in charge of anybody. Trust me on that. I know that. All right. So anyway, so that was an interesting one. Let's go look at this one. This one is this one wants public cloud as well. It'd be funny if these were for the same job, but just from different recruiting firms. That happens sometimes. This one's contract W-2. It's about 125 to 130 a year. It's not bad. That's not bad pay. 125 to 130-ish. And by the way, if you ever say, Scott, how can you figure that out? You go here, you pull up a little calculator, and you say $60 times 2080. That's okay. That's the low end, 124. So I was pretty close. And then the high end is 63 times 2080, 131. And does anybody know where I got the 2080 from? There you go. Boom. If you've never seen it before, that's where those that's the numbers right there. That's what that job pays. Not bad. But let's see what they want for that. They must have able to get on. Oh, this is for the same job, guys. This is a different contractor for the same job right here. So both of these are the same roles, but they want enterprise infrastructure lead, system admin, and then does it even say? Yeah, it looks the same. It's at 75-25. Oh man, you couldn't make me do that. You can make. I don't roll. I don't. Well, there's other reasons I wouldn't do that, but that's not people management. Guys, I have enough people management with my college students. I have about 120 college students right now that are just, there's nothing wrong with them. I'm not like saying anything bad about them. I'm just saying I do enough managing of people's lives right now that I don't need to be managing more in a work environment. Oh, this is the same job, LG. This is the same job with a different contractor. So these are contractors. These two right here, these are two different contractors posting the same job. So Expert Technology is probably some kind of whatever, and then SR International is something. Where's entry-level Linux roles? Yeah, so infra admin, I tell people one of the things about Linux systems administration that you're going to find is I don't want to say there's no entry-level roles, because there are, but people are handing you the mantle of, and you're like, it's almost like they're putting the weight on your shoulders. Like, if you ever watched any of the old like strongman competitions, like powerlifting, and they would go take the weight, and then the guys would hold the weight, and then they'd move the little bars away, and then they'd do their squats or their, overhead presses or whatever. But they would tell them take the weight, and then they'd let it go, and then they'd have to do their lifts or whatever. It's kind of the same thing. You're taking the weight of controlling this entire system. It's a lot of responsibility. Like I tell people, when you sign that doc that says you've got a document that says that you're going to be root or administrator for a company, and you understand what that means. I've told my wife this before. I could go at any given time, and then look, you don't think this too much, and you don't say it out loud, but I'm going to tell you guys, I have been wherever I'm at when I'm root. I could push one button, especially with Ansible, and I could cost that company millions of dollars. I could cause something to be on the nightly news if I wanted to, and I'm 100% positive that they would not recover within weeks of what I could do. And knowing that is a huge responsibility, right? Like, You know, again, like, I mean, not to overstate it, but like, if like Legolas had just pulled out his bow and shot Aragorn in the side of the head while they were standing there, and then just looked at everybody and been like, "What? The king's dead. What are you gonna do about it? Like what the fuck's everybody gonna do?" It's the same thing. Like my point though is you have a lot of power, and you've got to. So my point in saying all that is you've got to prove to somebody when we're talking entry level positions that you're ready to take that. And a lot of times you've got to get into an organization through like network operations, which is like monitoring stuff, or security operations, which is again tracking things. And I have this drawing I show you guys sometimes. Hold on, where's my drawing at? Let me pull up my drawing for you guys here. This is the way. What the hell's going on here? Get out of here! Don't save. Get out of here. File, open, recent. I know it's here somewhere. Linux Systems Administration. This is my Linux Systems Administration stuff, right? And I'm constantly showing you guys this. This little drawing right here is something that I did. It comes from the... Huh. I don't know why I don't have it over the top anymore. Hold on. Change that to white. And then grab it. Bigger. This is what's called the PPDIOO methodology, right? It's prepare, plan, design, implement, operate, and optimize. And sysadmins tend to start over here on the left. So, yeah, if you can't find entry-level stuff, sometimes you've got to look, and it might not just be Linux administration. It might be network operations, right? Like NOC stuff. Well, let's keep looking at this. I'm looking for Linux monitoring, right? Let's keep going down. Application support engineer. What's this one want? Application support engineer. They want you to know a whole bunch of stuff that doesn't have anything to do with Linux. Monitoring, that's got a little to do with Linux. And now if you've done some of these labs or if you've followed along, you understand how to do monitoring. Mainframe's still around. Yeah, AIX, HPUX, those are still around. They're not any harder than doing anything else on Linux. It's all command line, guys. It's all POSIX compliance for the most part. Splunk. You can get training on Splunk. They have a university online, so you could go get some skills in that. But Unix and Unix Linux, you can get skills in that anytime. What do they want you to... That's all they tell you. And they just want you to have either consulting experience, training, military experience, or education around system engineering or technology architecture. So you just need to understand some of these basics. This wouldn't be a bad one to get in. And then it's a contract, so they know you're not going to stay there forever. Yeah, there's still a fair amount of Unix bouncing around there, guys. That's still out there in the world. Let's see what's another one. OpenShift Linux Administrator. This is what my brother does. He does all OpenShift. He does it for way more than that. Way more than that. Let's see. They want you to have Linux, Apache Kafka. So I've shown you guys how to use Linux heavily. Apache Kafka we've messed with. Splunk or Elk Stack. Elk Stack, it's still around and kicking, but it's less common than it used to be. But it's still out there. They want you to have some Red Hat. They want you to understand Linux shell scripting, so that's Bash, Python, and then YAML, JSON type stuff for probably your Ansible and probably whatever different configuration tools you're using. And then you need to understand things like VMware, so they probably have a VMware like ESXi infrastructure, that kind of stuff. This isn't a bad place to get on. That's pretty good pay to start, you know. Shortlist candidates will be invited for a 30-minute call. This is on site, so that's not always good for everybody. It's in Phoenix. Day one on site, 5 days a week. So I don't know if that's 1 day on site a week and then the rest is just working remote or what. But just a little bit about the company. I've never heard of them. Oh, they're a contract company. So there you go. All right, so this has all been contract stuff so far. I know that this is that's a contract position. I don't know about this Viva. That also these all look like these are all contracting groups. I wonder if they have a thing over here where we can do Only direct hire. Yeah, let's see if we can do only direct hire and see what's there. Oh, that's weird because that's definitely not a direct hire. We just saw that that's not a direct hire. So both of those are not. That's not correct. They want you to be an information system security officer, and you need top secret clearance. So that probably hurts a lot of people. There's a lot of insurance in Arizona. There's State Farm's out here, pretty big. AAA's out here, pretty big. As is what's that organization that's always sending me bullshit? What's the one that's with vets? USAA. Those assholes. They're always sending me stuff because I'm a combat vet, so they're always like trying to get me to go do shit with them. Senior storage. So look, storage engineer is going to come up when you look for Linux. Not bad pay. Not bad pay to start. That's not bad pay in general, but I'm saying that's definitely not going to be an entry level role. But what do they want you to do? Let's see what they want you to do. You got to have a secret clearance. That's not too hard if you were born in the U.S. A little harder if you're outside the U.S. if you're born outside the U.S., but easier if you've lived in the U.S. at least 10 years. So, and it's for the Army Corps of Engineers, so you definitely have to have been in the U.S. the last 10 years for those secrets. So that's probably a DoD secret clearance. 100% virtual, work from home, and you have to be CONUS, which is continental U.S., so the 48 states that are local, of which Phoenix, of which, not Phoenix, Arizona is the 48th of the CONUS states. The only ones that were brought in after Arizona were Alaska and Hawaii. What do they want you to know? Bachelor's degree or 9 years of experience, so that's not entry. You're going to do large IT infrastructure supporting 15,000 users across 100 sites. That's kind of big. I'd call that mid-level, mid-size. You got to do Windows or Red Hat, and they want you to have certificates. They want you to understand root cause analysis, risk identification, and risk mitigation. I like how that's written, so I'm going to actually put that into my notes over here because those are all things that we can talk about when we do the engineering role. They want you to have a CASP Plus, which is the higher level of the what's that? That's a higher level of the CompTIA for security, or a CISSP, right? And then they want to pay 120 to 160, and then they don't require COVID vaccination or boosters, so that's probably useful for some people, right? CISSP is, I hold that, but I also don't want to go do storage engineer. It's interesting, they say you have to have all this, but nothing they have here has anything to do with storage. Like, I don't see a single storage technology on here. This is the only thing about, like, operating systems. And they say storage infrastructure, but that's not storage, that's not storage, that's not directly storage. That's not storage at all. Not storage, not storage, not storage, not storage, not storage, not storage. Kind of related to storage. That's interesting. No, in the U.S. you can't. No, in the U.S. if you want a top secret, you have to be in here at least 10 years, and your contacts can definitely keep you from getting a clearance. Yeah, I mean, I don't make the rules, guys. I'm just telling you. So look, storage. Those might all be the same role. They want a cloud senior site reliability engineer. So that's like a good one to go read your books about. Your SRE books, right? So there's free books, SRE.Google books. These are free books for you guys that Google provides. And I will link them to you because I like to make sure that you guys have them. Lord Processor said, Professor, is this drawing in the Discord? Talking about this one? Which one? This one? This. I've put this in the Discord before. PPDIO, that's a Cisco thing, but it's a deployment methodology, right? It's design. It's originally from Cisco. Let's go ahead and Control S that. We'll just save that. But yeah, you tend to start over here as a sysadmin. Over here in the operations, keep the lights on, network operations center, security operations center, help desk. Like you gotta be. Sometimes you gotta suck it up, man. And this sucks, but like especially when you're young. I mean, if hopefully before you got a family, network operations, security operations center, it's much easier to get in on a third shift. Third shift is like 10 p.m. to like 6 a.m. or like 8 p.m. to like 6 a.m. a few times a week, and it's brutal. I did that shift early on in my career. It's terrible, but some people love it. I did not love it. Network engineer, so now they're back over to network. Lead site reliability engineer. Remember I told you guys when you do Linux, they want you to do everything. So we're asking for Linux and monitoring, but we're getting all these other things. I don't really want to do any of those. Site reliability engineer. Again, you might have to rebrand and work on your resume a little bit and have some different versions of it. What do these people want? HPC engineer. So let's see what they're looking for, because this is the type of role. So that's super low. I can already tell you right here, if you call it HPC, you're not going to get people for 120. If it's high performance compute and they want, well, let's see how senior they want this guy. See what tools they're using. Python Bash, okay. Linux and network fundamentals. Configuration management with like Ansible. They want you system monitoring, alerting with Prometheus, Grafana, Telegraph, Splunk. So you can do those labs and know these three right off. LG, I think you just have to. A lot of people fall into these roles, man, or you come in through some other method. But they want you to know low latency networks, GPU based systems. So low latency networks will be like your InfiniBand and those kind of things. GPU based systems, so you're using like NVIDIA systems, and then high performance storage is your Lustre, your GPFS, your Weka nowadays is a high performance storage system. So those are all ones that we've talked about. And LUSTRE, Lustre. Yeah, that's how you spell Lustre in that context. Slurm, we showed Slurm, platform LSF or LSF. So that's good. And then they want you to have this. So this is not. This one's a more, I would call this more entry level, but you can get skills in all of these things. You couldn't really get skills in these two things without being in there, but I think every other thing up here you could build your skills outside of this role. You could build them up in Killer Coda Labs that I've shown you guys. The AI thing is separate. I mean, look, none of this stuff here is asking you for AI stuff. They want you to understand the platform. So it's an HPC engineer, but it's a platform and network engineer at its core because of what it's asking for here. All of these things here for these requirements, I think you could do. So they do want you to have a bachelor's degree, but again, you can get away with bachelor's if you've got skills. Look, proof of exceptional skills in a related field. If you've worked in something or you've built projects in this, you can supplant some of that stuff. I'll actually grab this and add these requirements to something because I kind of want these. I like that. So, all right, guys, I'm going to take a quick break because I want to go walk around a little bit. Take our hourglass out. If anybody wants to keep hanging out, we're just working on stuff. We did the Linux systems administration for the first little part of this, and then we're just going longer now. This is all bonus stuff. This is all past the actual course. The course was the first hour or so. Now we're just kind of hanging out. But we're still working on stuff though, and I'll be back. Keep working on stuff. Let me know if you guys have any questions. Go get me some more water. Throw my monster can out. All right. I have my water bottles. I'm back, but being back doesn't take away from our timer. I'm gonna leave the timer up so that people can go take their breaks or whatever, and then we'll just kind of hang out here. What did we do today? We did the Linux Systems Administration Unit 11 recording, and then now we're just kind of at the end, and we're done with the actual, course part of it. And now we were looking at jobs on DICE and looking for entry-level Linux system stuff and what people kind of want. The different types of engineers that kind of pop up. And this is, by the way, that's my current title is HPC engineer. I'm a principal, but not with AI infrastructure, although the system that I just finished building is heavily being used for AI stuff. We used Werewolf, we used a whole bunch of Mellanox, and Mellanox is owned by NVIDIA, some of you guys know that. One question, is it possible to have experience in HPC when you experiences small home lab cannot afford all the InfiniBand hardware? LG, yeah, you can kind of learn what you can learn. In my mind, the stuff is just, it's kind of like, in my mind, it's like micro concepts and macro concepts. And what I mean by that is, like, you might not know InfiniBand, right? You might not know InfiniBand, but it's IP over InfiniBand, right? So it's IP networking. So it's still it's still network. When we look at a device, it is still, there's still just a device on our machine, and the device is either there or it isn't. So when I look at the networks, it's just an IB device instead of an ETH0 device or something. So it's IB0, IB1, whatever. It's still got an IP address that has to be correct. If the device for some reason isn't there, I just got to use like IBstat or IBstatus to see the status of the device. If the device isn't showing up for some reason, I go and I look at my LSPCI to see if the PCI connected device, right? It's in a PCI slot. Is it connected, right? So there's that. Then I go look at the kernel drivers, which are all Mellanox OFED drivers, to see if the OFED drivers are loaded. Then I check the version of OFED against the other machines in the cluster that are working to see if something's busted. So where I'm going with that is, you don't know InfiniBand, right? You don't know that type of networking. But every single other thing I just said was just basic Linux systems administration stuff, right? Like, can you check out, can you do all right, here. So we're still just answering a question on break. Let's go to Rocky 1 real quick. Can you do IP adder and see that, well, there's not an IB0 there. So this is a problem. If I expected IB to be on this network, there's a problem. So then I do LSPCI to see, oh shoot, there's not even a card here. Well, I can do a D-message, and then grep for like, I know that my cards are called, we call them, well, they're Mellanox, so you could probably look for Mellanox. It's not there, obviously, on this box, but, ConnectX, that's what they are. So it's ConnectX, right? So ConnectX, and then I would expect like a ConnectX 5, 6, or 7, depending on the generation of hardware. Well, so I can go to a box very quickly. If I have like 100 servers, and one of them's just like, I've wiped all 100 servers to my brand new version of my build that I have extensively tested. Guys, before I go push out to 100 servers, please believe I have extensively tested that against that hardware on 1 or 2 nodes, right? And I push it out to 100 nodes that I expected to be the exact same, and one of them just doesn't come up right. It builds, it does all this stuff, but it's something different. So I go, well, what the heck? So I go look at it, and I had the expectation that all 100 were the same, but I don't know all the history. I don't know how these nodes got here, right? I wasn't around for that. So then I go look, and I do these very simple things right here against that system, and I find it's a different type of ConnectX card. It's a different speed. It's not EDR, enhanced data rate, instead of like HDR, which was one of the older technologies, like I don't know, it was called like hyper data rate or something. I don't know, but it's slower. EDR is like 200 gigs per link. It's pretty fast. But my point is, all these basic things, LSMod, grep for OFED, are my OFED drivers in, RPM-QA, grep for OFED and see how this OFED, there's no OFED, but see how this is different than the other nodes that I'm dealing with. That's all. Everything I showed you right there is simple Linux administration. But I had to know what to look for, which is the macro. The macro is, I can't say I know InfiniBand if I've never done InfiniBand. But what does somebody who knows anything about InfiniBand do? What I just showed you. All those commands right there are the exact same commands I would have used. So this is one of those examples. Have you guys ever seen this? The meme of job v interview. You guys ever seen this meme right here, where this is the technical interview, but this is the job? This is like the this is a huge, like, this is a meme that's like huge. Like, this is true. They give you these super hard requirements and they filter everybody down, but the job is nowhere near as difficult as it sounds. An HPC engineer is not nearly as difficult as you might think. But you still have to know a bunch of Linux stuff, right? So I tell you guys, knowing the Linux side of things will benefit you in every other way. Same thing with security. Knowing security stuff and security concepts will go through everything else. In my case, I briefly touch HPC to kill and restart bad nodes. When I see a job requirements asking deep knowledge of HPC, I know it's not for... Yeah, well, I mean... that's fair enough. This one looks like it's probably one of the easier or lower requirement ones to get in. All right. See some of these other ones. We're just messing around right now. Manager, VMware engineer, principal infrastructure and ops engineer. That's up in Minneapolis. Let's see what this one. This one's not going to be entry level. It's called principal. What's this one say? Review the work of others. That's common. Develops innovative approaches. That's common. You have to have opinion. You have to be kind of opinionated. The higher you go up, even though I don't like being opinionated, you do have to be more opinionated the further you go. This one's heavily in Azure, so you probably got to spend some time in Azure. So this might not be for most people because it's principal, so you probably have to spend some time in there. Dynatrace observability and monitoring engineer. Okay, so we wanted monitoring, but we don't know this tool well. It's 87 to 139. That's a ridiculous range. That's I don't know if I've I don't know if I've ever seen a range that large for anything that was real. So that seems super weird. But let's go look at what the job is, because I'm saying that's like not even quite senior engineer pay, and that's probably like staff engineer pay almost. So that's such a huge swing. Anyways, let's go look. They want you to be able to build, implement, and tune dashboards and alerts to achieve observability and monitoring business goals. Okay, so you got to work with people. You got to talk about service level objectives, service level indicators, service level agreements. Okay, they want you to know Dynatrace, but a lot of times you'll see when you read these, maybe on-prem and cloud monitoring solutions. So cloud monitoring will be whatever, if you're using Azure or AWS, whatever that is. Serve as a problem-solving partner and cross-train others, so you're going to probably have to work with other teams. So I think there's things in here that you could probably get some things. This one might be one of the ones that knocks you out, but if you're strong enough in other areas, and maybe you don't know Dynatrace well, but you know some other monitoring tools well, maybe that'll help them to... But I would say in this, they probably want somebody that's heavily involved with Dynatrace. I've only used Dynatrace enough to deploy it a few times. Like, I've written some Ansible playbooks that deploy it in a company, mainly because Dynatrace has these specific keys for each of your different apps, so then you put a different key in each time. Yeah, and they want you to monitor, yeah, well, on-prem and then cloud, so that's probably your public cloud out there. So on-prem is your local stuff, and then cloud is your public stuff. Yep. By the way, so look, here's another thing. They want you to know New Relic as well. New Relic is a different tool than Dynatrace. Or did Dynatrace buy New Relic? I might be thinking incorrectly. They want you to know AWS and Google, so they want you to know two. So if you said that you had strong CloudWatch experience, that might help you get in there. They want you to understand AIX, Linux, Windows, and Ansible automation. If you use Ansible, you can touch all of those, so that's good. They want you to have these other things, which are kind of, these are not quite, direct Linux engineering skills, but I think that that's definitely something that you could talk up. And then here's your preferred qualifications. Again, they want you to be really good with your Dynatrace stuff. 5 years, in fact. But if you'd been doing Linux systems administration and at least been, keeping that running, that might help, I guess. AIX, Unix as well, yeah. Yeah, I mean, there's one of these things you gotta just keep looking, right, until you find the type of job that you want to do. They want an infrastructure engineer for DNS, so that's heavily network, but it might be Linux under the hood. Discover is local to Phoenix as well, but it looks like they're also up in Riverwood, Illinois. So, I don't know about Viva. Don't know anything about them, but they want a performance engineer. Let's see what this one looks like. Get out of here. Why are there ads on an already ad-based job site? All right, anyways. The role, they want you to know you're going to test their suites before release, and they want you to have experience with performance engineering and benchmarking. Those are things that I can help you with, or at least point you to the things that you need to do that, if that's interesting to you. They want you to have performance engineering with JMeter, Load Runner, and similar tools, and profiling tools. I can't help you with that as much, but I can still show you performance engineering and benchmarking stuff because I do that all the time. Root cause and performance bottlenecks. So you need to see performance bottlenecks are typically the area where, as you start to load up a system, what is the system part that stops working? That tends to be what we call a stress test. Once we stress a system and break it, then we have found its performance bottleneck, right? And then we can go improve it or whatever. They want you to know Linux, Docker, AWS, Git, Artifactory in terms of both tools and systems admin. So they want you to have some of that experience. And this one right here is, I like that this is at least up front. They are not asking you to be a Linux engineer. We were looking for Linux and monitoring, which showed up in here, but they were not trying to make you they're not trying to call you a Linux engineer and then force you down into performance engineering. So at least they're upfront about this. I think that this one is their life sciences industry, so they're doing like people stuff. There's probably some HIPAA stuff going on in there. I've never heard of this company, Viva Systems, but one of the other things you can do is you can go look it up, see what they're doing. They want you to know some Java, Python, Shell, yeah. Probably, I mean, if you're doing performance benchmarking, you probably need to know some of that stuff anyways. Got to be able to work in the U.S. They're not sponsoring, so that's not going to help anybody come in, so it's one of their requirements. Sometimes you have to be a U.S. citizen, depends on where you're at. Why would you want to work here? And that's another one of these huge ranges. That's senior engineer pay up to like maybe senior staff, as far as like some engineering paths, maybe just staff, but that's still like a huge swath of engineering pay. They're in San Francisco, so you might need to go there. And does it say 100% remote? It does say remote, so you could work for them remote. All right. Some of the other things, yeah, bunch of tags on that. But yeah, I mean, you want to get some experience in performance engineering and benchmarking. What I would tell you to do, if you said, Scott, I don't have anywhere, I don't even know where to start, but I want to be a performance engineer and benchmark. Well, if you're not going to go to college, the next best thing is to get certs. And the certs that I know of that directly deal with performance engineering and benchmarking are your Six Sigma stuff. Six Sigma is always going to be good for that. Right? We're right in our Discord here. Lean Six Sigma. Lean Six Sigma deals with just-in-time manufacturing and manufacturing processes, but that also is software manufacturing. This deals with removing errors from processes, which is also part of that. And then I have some stuff in one of our Linux systems administration talks on that. No. Where is that? I'd have to go find it, but I have some stuff on benchmarking and analysis and stuff. And we'd talk about that sometime. But anyways, the point is, yeah, performance engineer. This one I wouldn't say this was out of somebody's realm to stretch to if they wanted to go that route. It might take a little bit of time to get ready for that kind of job. But this is one of those things too. You got to make sure that's something you want to do before you go jumping over into that type of role. Do they say years of experience? I don't see anything here about years of experience. They just want you to know this stuff. So I think a lot of these things you could prove out. Distribute. Yeah. I think a lot of stuff you could prove out with having that on your resume or on your portfolio, that kind of stuff. Yeah, performance and benchmarking are all about looking at what's going on. Does it say 6+ years? That's fair. I mean, they are calling this a senior performance engineer, so. Still don't see 6 years, but maybe I can't read. You guys gotta remember, this is one of the other things that's big is you guys will find that first line of requirements. Oh, okay, there it is. This is a big thing for people. People will say all the things they want, but they'll be willing, if they found somebody that was really good at this and really good at these things, they'll waive this. You'll find that across the board. The only place you will never find that is in a government job. In a job that's for like the U.S. government, if you're on like Fed jobs or usajobs.gov, and they have like 7 requirements, those 7 things have to be checked or you will not be getting the job. That's how requirements work for the government. But these kind of guys, they want you to have these things, but they're willing. I mean, if you had really, really strong, maybe you meet this and you're really good at this, but you don't have any of this stuff. Sometimes they'll go, I'll give them a shot. We can train them in the way this tool works or whatever. Maybe that's a bad example because those are things you really need to know. But they can worry about the other stuff. So, all right. Anyways, let's keep looking here. I didn't strictly say senior or junior for any of this stuff either. I had a buddy he just left General Motors, one of my old security guys. Application engineer, that's software stuff. Let's go look. Application engineer. They want you to write code. Cassandra Couchbase, that's more DBA, but it probably just mentions Linux. Senior data analytics, yeah. Site reliability engineer, maybe. That is very similar to a lot of what people want in Linux systems administration. OpenShift Linux admin. Is this one similar to the other one? Contract, they're paying just over $80K a year, so that's not terrible. That's what I would consider like your entry level Linux. We looked at this one earlier. Same things. Splunk, Prometheus, yeah. Managed stuff. This is a shorter version of the same exact one from earlier. But those are all things that you could spend time learning. Apache Kafka, you can go spend time with that in Killer Coda Labs if you want to get better at that. There's a lot of free stuff online to learn how to use that. Here you go. Now, we talked about this. Third shift, night shift. I bet this position's way easier to get in, guys. I'd be willing to bet this is way easier to get into any of the other ones. But are you willing to work the night shift? Younger people in their 20s, probably before you have families, you're probably more likely to want to go do this. And they understand that there's some churn in this role. But look, this has been open for 37 days. They want you to do hardware installation and provisioning. They're probably willing to train you in this type of role. They want you to go work in, a lot of this stuff, they're going to have a lot of turnover or whatever. But I mean, there's a lot of area in here I already look at this, like decommission lifecycle and data center hardware. That's pulling equipment out of the racks and keeping track of it, right? Just going through your notes and putting the right information into the right, whatever their tooling is. Inventory process, order replacement parts and return failed parts as required. So you're going to like the parts bench and making sure that parts are there for, whatever our normal churn through is of parts. You got to know your structured cabling, right? That's your TIA, EIA 568A and B. You got to know how to label and troubleshoot fiber, copper telecom cables. If you don't know how to do that, they'll hand you a toner and a tool, and they'll help train you on that stuff. So that's always pretty good. System power supplies and cabling installs. So you got to go learn some power stuff. A lot of this stuff I'd be willing to bet they'd train you on. Almost all this stuff. What do they want? Career level IC3. I don't even know what that is. And then, yeah, daily center. People work multiple shifts, so you're the night shift. Troubleshoot stuff. And you got to act within service level agreements, so they probably want you to pick up tickets within a few hours or something, you know. They want 2 years working in an IT environment. I'd call this pretty junior. Yeah, I'd call this pretty junior. Those are all just terms that they want you to understand a little bit, but you can pick all that up pretty quick. And probably because you're going to be standing there at the machine sometimes watching them boot and then telling somebody what's going on. They want this, but it's this only preferred. Again, you can typically get away with all that. I'd say that's probably an easier one to get on, but again, you're working the night shift to start. Do that for 6 months to a year, and then move over to like a day shift, and then you're building up your IT skills. Hey guys, I mean, I worked in a data center a long part of my career, even when I was called a senior engineer. I was still working in data centers almost exclusively. So, in fact, at Lockheed Martin, we were a factory to a government site, so I had like 7 different data centers I would go in, and sometimes I had to spin the lock and actually go into a separate SCIF environment. You know, I'd have to log in when I got in, and I'd have to lock it when I left. So there's a fair amount of stuff like that kind of always going on. This will show you a lot about a lot of stuff, and I'll tell you what, as any other jobs go away, they still need people to work in the data center, because you know they still need to be able to rack and stack the devices and troubleshoot them and all that kind of stuff. So still a fair amount of work being done in data center. I was in a data center when I was in Hawaii. Spent time in that data center that whole time I was out there. Not the whole time, but when I wasn't training people, I was in their data center. Lots of data center work. Lots of that. Maybe some site leads. And they're probably ramping up for something if they're doing this many data center techs. Then they've got a lead job, so that's good. Yeah, a lot of this other stuff. It does sometimes go pretty lean on the Linux side of things, guys. But the main thing I would do is keep networking, keep finding, you know, other interesting things that are out there. I'm constantly showing you guys. I'm constantly trying to bring in people to talk to you guys as well, for you guys to kind of network with. Our end of the year party, which is going to be January 4th. Here, I'll show you guys. In that little group, I'm trying to bring in. Although it's super annoying to me that the here's our New Year event. We got 27 people say they're coming, but we typically have like a lot of people throughout the day. But that event, I'm going to try to get some recruiters to come in and tell you like what their companies are doing, like what technologies that they're asking about, and then I'm trying to get them to come in for like little 20-minute blocks if I can. And then like if you have any of those skills and you want to contact them, I'm just going to say, I'm going to tell them, give your contact information to these guys, and then anybody that wants to contact them can. You know, that's kind of my plan anyways. I'm trying to get the recruiters that I know on LinkedIn to reach out. Although, man, if I could complain for a second, everybody on LinkedIn wants to connect with you, like recruiters and stuff. But then when you ask them questions, even direct questions, and you're like, hey, I want you to come talk to this group, they blow you off. And I get when they used to blow me off when we had like 600 people or whatever. That's, you know, maybe that's not worth it to them. We got like 3,400 people almost. Like, I would think that they'd want to come and have a chance to talk to a few hundred interested engineers. You know, but I literally can't even fucking get these people to message me back. In fact, I've told people, like, if anybody messages me that's like a recruiter just trying to be like my friend on LinkedIn, I'm not looking for friends. Nope. If you're not going to respond to me when I text you or when I message you, go F yourself. Go be friends with everybody else on the internet. Like that's not like a social media site. That's supposed to be a job site, you know. So, yeah, and I'm looking for. I have some that I know that are internal to companies that are actively looking and posting things, and they won't message me back. And I'm just like, just start purging them all off of there. And then the only people that'll be on my LinkedIn are people that I personally know from work and former college students. Because that's all. I mean, I don't give a shit. Like, I don't know. The internet in general is not a real place, so I don't care. Oh, also, MPES is going to come and talk to you guys about Kubernetes on the 11th, and that'll be a really good talk. So, oh yeah, IOFault. They're constantly doing stuff like that. So, all right. Anyways, you guys got a bunch of stuff on here to go play with if you want. I'm probably gonna drop here. Let's go find somebody to raid. We're not really doing too much on the Twitch side of things, and we'll go to our end of stream here. And if anybody wants to hang out, I'll be down in Discord most of the day. The grandbaby's coming in town. Well, the grandbaby and the kids are coming in town, right? So yeah, they'll all be here. So I'll be around though. What app scam? Yeah. Man, there's always going to be scams in these places doing whatever, so it happens. All right, we don't have enough people even raid, so we'll just call it here. This was the Unit 11 course. I'll be putting it into the watch list and stuff, and then anybody that makes it this far along will just have looked at some job stuff with us. So, all right, thanks for coming, guys. I will talk to some of you guys later. Take care.